Hey, what's up, eighth grade? Mr. Catlin here, helping out with your homework for the week. We've got lessons 5 through 7, pretty short week, and we got a quiz on Thursday. So I'm just going to go over these problems with you. I'm sorry, a little bit late posting this one. I was out sick yesterday, so that's what happened there. But let's look at these situations. We have to mark whether they're true or false and explain or show their reasoning. Now, a negative exponent, we learned yesterday, the rule that we decided was that if we have 10 raised to the power of a negative n or some kind of negative number, then that is equivalent to taking that 10 and making it into its reciprocal, which would be a tenth, and then multiplying that 10 by itself the number of times it's in your exponent, but making it positive now that it's in the denominator. So negative exponents really essentially just make really small numbers, like 1 over that exponent to that power. And so when we look at this situation here, what should be happening based on this rule is 1 over 10 to the fifth. But the problem is what they tried to do, instead of flipping the number, they flipped the signs of the exponent to the number in the base. And that's a big no-no. So that's the reason why this is false. Explain or show your reasoning. This is what should have happened, and this is what they did. All right. We don't want to throw negatives into the base and multiply that to the power of 5. We could say something like negative 10 to the fifth power is much larger than 10 to the negative fifth. 10 to the negative fifth is going to be 1 over 100,000, right? Which is teeny tiny. And negative 10 to the fifth is going to be, 10 to the fifth, which is 100,000, but negative. So I guess not really much larger absolute value. We can say that. It has much larger absolute value because it's so far from zero, whereas this one's getting really close to zero. But it's definitely false. All right, the second one here is showing that these two things are the same. Well, this kind of goes back to a rule that we wrote earlier in the week of last week, where if I have a 10 to the power of, say, m, and I take that to another power, what I can do is I can just multiply m times n. Well, if that's the case, then in this situation, we would do 2 times negative 3, and this would give us negative 6, right? We could say that this is going to equal 10 to the negative 6. And if we do negative 2 times 3, it doesn't matter if we swap signs, we're still going to get 10 to the negative 6. So both of them would still have the same power, negative 6, whether we multiply 2 times negative 3 or negative 2 times positive 3. So this one is true. Excuse me. They are equal to each other. And another way you can think about that is you can think the first one is 10 squared to the negative 1/3 power. So what that's going to do is it's going to take those 10s being squared 3 times, and it's going to throw it into the denominator like this. The other one, the way that you can think about it, is you're doing 10 to the negative 2 power, which is a tenth times a tenth, because you're flipping it, and you're doing that in a group of 3 times. Like you're going to do that 3 times. Either way, whether you do it the first way that I showed or you do it the second way that I'm showing right now, how many 10s do you have in the denominator is one way to think about it. Well, you've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And your numerator is going to be 1, whether you multiply 1 over and over again or you just set it as 1. So this one is true. This one was false. Now, this one right here, this one falls under the category of rule number 3, which is if I have 10 to the m power and I divide by 10 to the n power, then I can just take 10 to the m and subtract whatever n is. So I can subtract 3 minus 14. So this is the same as 10 to the 3 minus 14 power. Now, 3 take away 14 is the negative 11. So this one is true. All right, so that does the first part. I'm going to go ahead and do lesson 6 as well, since we did these lesson today on Tuesday. All right. So we'll talk about other bases. Your bases don't just have to be 10 anymore. We found out today in class that your bases could be other numbers as long as they're positive and they're not negatives or zeros. We can have 2 in the base. We can have 7 in the base. We can have all kinds of numbers in the base. We even found out we can have fractions down there. But let's look at what Diego's trying to do here. He's trying to take this expression and write it as 2 to the 3 times 2 power. Now, the problem with Diego and the mistake that he's making is that he's trying to use rule number 1. Now, rule number 1 states that if we have a number to a power and we multiply that same number to a different power, we are supposed to add them together. Okay? We're supposed to add them together. So the mistake that was made is Diego should have added 2 plus 3, right? He should have added 2 plus 3, not multiplied them, and got 2 to the 5th power, which is the correct answer for this. All right, so there's the problem that he made. Didn't use the rule right. He was supposed to be adding them, which would be right here is the problem, right? Should have been a plus. All right, let's look at what Andre does. Andre is trying to do these rules, but he makes a mistake too. He's got 7 to the 4th in the numerator. He's got 7 to the negative 3 on the bottom, and he's trying to rewrite this as just 7 to the 1st because he's subtracting 4 minus 3. And, that makes sense. I mean, the rule states that if you have x to the m power and you divide by x to the n power, the rule states that you can just take those two powers and subtract them. I mean, that's what the rule says, right? But here's the problem with Andre. He should have been plugging in 4 for m and plugging in negative 3 for n. All right? He just did 4 minus 3. This should have been 4 minus negative 3. Okay, so Andre should do 4 minus negative 3, which is equal to 4 plus 3, which equals 7 for the exponent. All right, that's an E, exponent. And if his exponent was 7, the answer should have been 7 to the 7th power, not, sorry, my pen's not working great. 7 to the 7th power, not 7 to the 1st power. All right. And that should cover it, guys. We learned that we don't have to have 10s there anymore. We can have any number. And we can apply these rules from when we have negatives, when we have positives, when we have exponents that are being divided, multiplied. We also have power to powers. And we also learned that anything to the 0 power is equal to 1, which we'll apply plenty of times moving forward. That's all I got, guys, for lesson 5 and 6. I'll piece these together for your homework. And don't forget to have that due by Thursday this week, as we'll have a quiz over these lessons.